फोन में से रेस भी करेंगे वो डाटा को नेट चल रहा है इसका तो नहीं है कैप्चर करो frequency signals in this area start is this Dr. Mother Sharma, Secretary for the International Short-Term Trading Program, which has gained its popular name as ISTTP-4, with a chosen topic on methods, modeling data, and tools of relevant information. Other component aid enhancing quality and excellence for certain consumer scheme and commissioning and state data. College education, government process and India organized by the large regime, government autonomous college algorithm, which is formerly known as RRC, and assigning it from this newly revamped Jury Law. On the behalf of our internet principal and from Congress, I welcome you to the 4th day ISTTP. Giving encouragement to others is the most welcome gift for the results of it. Unlimited spirits, increased self-worth, and hope for the future. Sometimes challenges and struggles are exactly what we need in our lives. May you welcome every effort, every struggle, and every challenge. May you open your wings and fly. After the international short-term training program, Jordan और स्वागत आप सबका अभिनंदन। वास्तविक ज्ञान और जीवन का प्रतिनिधित्व करती है। हमें हमें जीवनी है। Master Smithicus, young scientist and the or Kalaki. Master Smithiki Aratna, Karthi Vibham is taking for that. We are bringing the whole day of ISTTP-4 by now causes and worshiping her. I like to cast recap from the third day of ISTTP-4. Our first speaker constructed Adil Pachigani is involved on the list and now he's working at the department environmental sciences and physics. After that, we have another lecture on sustainability and economics by Mr. Satyavanayana. Mr. Satyavanayana was working as associate professor in economics, BSR and Advanced College. After that, we had an engineer who was talking about sustainable technologies and what techniques by our working and save the environment. He was Dr. Bobudi, who's working as a lecturer in selection grade in Government Polytechnic, Karnataka. The fourth thing was that concluded by free forum and feedback, which was conducted by organizing you can mother earth within you. She's not outside you. Mother earth is just not your environment. And inside you intervene. It is possible to have real communication with the earth, which is the highest plane. We forget that the motorcycle and life cycle are one. What is the use of the White House if you haven't got a tall or a tall red planet? To me, being the environment a lush carpet of fine fingers or a spongy glass is more welcome than the most luxurious Persian. A nation that destroys its forest on the lands of our land, purifying the air, giving flesh strength army. Today I'm going to talk about that yesterday we spoke about the God eradication of poverty. Today we have God 2, which is the zero hunger. And the hunger touching food security and improved nutrition by 2030. No country can look at the environment unless it protects people, unless it provides food every it has in its land. So the most important thing to eradicate poverty and finish up hunger. So we will talk about later. Let me introduce with speaker who is Dr. who is working as a senior vessel and Tamil Maharashtra, India. He obtained his in chemistry in 1989. He obtained his PhD in 2000 from molecular chemistry from RTU, Nagaland University. Dr. Presently working as professor in the Department of Chemistry, Government and as I told you before. During his career, he is involved in the synthesis of characterization of nanomaterials as well as the development of SBR, nanocomposite materials, semiconductor materials, binding polymers, conductive polymers, TNC, and oscillators. Dr. has published more than 230 research papers in national and international journals. That's a good number. Markets communications and present 110 research papers in national and international conferences. He is a member of 28 journals of healthcare, Godwin, speaker, oriented benefits are the publishers having impact factor more than 2.3. Successfully guided 26 PhD degrees and connected current register or PhD has successfully guided 21 and third is putting down her and we can. We are so much pleased and happy to have you with us, Dr. Kule. Dr. Kule, if you don't mind, shall I complete my hunger program? Shall I complete the SDG gold mode if you don't mind? Because I just started and I shifted to you. So, my dear friends, I was talking about the project and we spoke about the yesterday. And hunger, food security, and improving environment 30. As I have told you before, no nation, no country can protect the environment until is carbon like every it has on its level. After decades of study data of hunger, as I mentioned, equivalence of undernourishment begin to slowly increase against energy. Today, more than 800 million people are hungry, to whom about 1 billion suffer from acute hunger, largely due to man-made conflicts, climate change, and economic shortages. The COVID-19 pandemic will now double this number, putting an additional 150 million people at risk of severe acute hunger by 2020 program. With more than 2 billion people potentially at a brink of starvation, a swift actions need to be taken food, humanitarian post at risk. At the same time, the drug taking global food agriculture system is needed if we have to nourish the 840 million people who are hungry and additional 2 billion people of the world who will have by 2050. Increasing agriculture from productivity, sustainable productions are crucial to help alleviate the battles of hunger. My dear friends, next time when you take a plate in a marriage, जब भी आप शादी में जाते हैं आप अपने पेट में खाते हैं, and when you fill it to the top and eat one food, that's one of three food. Just think about those 800 million people who are sleeping hungry. What's sleeping hungry? जो बिना खाने के कहीं भी सो रहे हैं. So think twice before you throw up. आप लोग बार सोचिए खाना फेंकने से पहले कि दुनिया में कितने आज इस तरह इस target of zero hunger and less by 2030, and hunger and access by all people, in particular the poor people, poor people in vulnerable situations. So, and I can respect, I would like to call upon your capacity to live with this lecture.
Yes, madam. Thank you, madam.
Yes,
I'm sharing the screen. Yeah. Is the screen visible, madam?
Yes, sir, I can hear you. I can see you. I can see your slides.
Is now visible?
Yeah, very much.
Okay. Thank you, madam. First of all, I thanks the organizer for inviting me for this full training that is workshop, and I also thank the principal of the college and the organizer, Dr. Mamta Sharma, madam, for your kind invitation. Here today I'm giving some uh, approaches, green approaches for the sustainable development. As we know, there are different ways, but now here one of the approach for the sustainable development is the green approach. So as we know, material science or the chemistry, and especially the chemistry is the central science. and it provides fundamental understanding needed to deal with many societal needs, including many that determine the quality of life of our economic strength. And as we know that uh, today we are living in a dynamic world, and in this case, we are in a knowledge-driven economy, which is linked with this science and technology. As we know, science and technology are different, but at the same time, they are complementing with each other. As you, all of you know that what is science? Science is the pursuit of knowledge and understanding for its own sake, and technology is the creation of artifacts and the system to meet the people needs. And as we know, the backbone for sustainable development is the science and technology. And as we know again that chemists invent and synthesize the molecule, physicists characterize the molecule, biologists make the use of molecule, engineer fabricate the devices out of these molecules, and public enjoy the molecule in different forms. So as a, there is a development of many technology day by day, which make life comfortable are closely related to the material. So there is a special branch of material science which show the relation between the structure and properties. And now engineering or engineers give the design to this material. So we can say that material, material science and material scientists play the important role in the development of our country. As we know, properties of the materials are size dependent. And we can say that material scientists claim that 21st century is the century for material science, that is especially the nanomaterials. So what is the green approach for the sustainable development? So before going to see that, there is a historical development, and if you go to the this perspective of historical perspective, so first of all stone age was there, then bronze age, then iron, and now at present we are in a now in advanced material. So this advancement in the material is day by day is going on, and new materials are uh, coming in the world. And what is now the with the advancement of the science, the scientists are changing the structure and the properties of the material. So this is the branch of science where the material science are very important part. So we can one can ask the question, what is material science and engineering? So this is the properties of material can be changed, structure of the material can be changed, and based on that you can design the material as per the requirement of the people needs. So when we are dealing with the material, there are four pillars of the material. First of all is the processing, where we have to apply the what is here. In case of processing, we have to use some methods for making the material. After the structure, we should have to know the arrangement of the material. What are the atomic, subatomic, microscopic properties, particles are present in the material, and after that some properties. So that properties may be mechanical, electrical, thermal, magnetic, or any some other characteristics of that material we should have to know. So and lastly the application or the performance of that material. So there are these are the four pillars, and so all these four pillars are very important to characterize the material. So in this slide it shows that as the time goes, there is a change in the industrial revolution is shown here. So step by step shown here. First of all, the steam engine came. After that, railways, and then automobile and computer. And after this, now we can say that next big step is the nanotechnology. So we can say that this nanotechnology is not a new, but from the ancient time we are using, and people are using this nanotechnology. But in the ancient time, people does not know about this material. So this is the Lagerfeld cup, which is kept in the British Museum, which is also known as a Roman pottery. And here is color is shown. It is a red color, and this color is nothing but the of the nanocold. So this paper, see the in the daylight, see the light emitted red color is the color of nanocold, and this paper already published in a Nature in 2000. So in short, we can say that this technology was not a new, but it is a in the from ancient time. Now there are number of applications in different field of these nanomaterials. So synthesis of nanomaterials and the methods, green approach or green method for synthesis, and then we have to use all these material for the particular. So in this case, here is shown in industrial viewpoint, we have food agriculture, in biomedical and environmental applications. So depending upon the application, we have to use the method and we have to synthesize how we can synthesize material, nano gold, nano silver, nano zinc oxide, or different materials. So this is the one method of green approach for the green method for the synthesis of nano silver. So here is a by using a reducing agent sodium boron, and this is the reaction is shown when silver nitrate present in the plant extract uh, react undergo reduction by using hydride, and we get this metallic silver. Hydrogen gas is evolved and some part of this compound are formed. So uh, already we have extracted so many medicinal plants extract. Here in example is shown extract which contain terpenoid levels, and also by using the reducing agent from silver nitrate agent, from that we can reduce and we can get metallic silver. Here is shown different uh, silver. So this is dark color, this is slightly light, and this is the different color. So here is shown the solution of this light yellow to brown yellow color of the silver particles. So this is one of the one method by reducing the metal, this plant extract, we get the metallic silver and silver nanoparticle. So in the similar way, we can use same method by using different reducing agent. We can extract the plant and then we can reduction. We can get different types of metal oxide or metal from the plant extract. So this is the green approach, and nowadays also bio-reducing agent can also be used. One plant is there, that is the lantana camera. We have extracted and we control by using a bio-reducing agent. A reduction process is carried out, and also the silver particle uptake can be particles can be capped. A protein layer can also be given. So by using this bio-reducing agent and the process, what is the silver particle can be coated by using a protein layer like that. So this is the another example of lantana camera plant extract is there. And also there are some sources of nanoparticle synthesis. Protein is there, amino acids are there, enzymes, lipid and carbohydrates are there. These are can also be used, bacteria can also be used as a source of the nanoparticle synthesis. So this is the metal precursor, and these are the fungi or bacteria can be react with the metal precursor and we get the capped here nanoparticles. So this is another route of synthesis of materials. And these synthesis of nanomatter, there are number of methods of synthesis. Can be synthesis from plant, from the microorganisms, from microwave heating, laser heating. So different methods have been shown here, and from the waste also. So synthesis of this material can be taking place. And by using also microbial reductant, different types of here enzymes, cell ligands, DNA template, protein, antigens, all these microbial reductant can be used for getting the particles. One more here, that is phytochemical which are present in the plant can also be by reduction we get the nanoparticles. So these are the different chemicals which are known as the phytochemicals which are present in the plant extract. So this microbial reduction of the metal can also be carried out on phytochemical present in the tea leaves are in plant extract act as a role of effective reducing agent and to reduce the gold or any other metal oxide or metal and act as a also stabilizer which provide a robust coating on the gold nanoparticles. So phytochemicals, these are the different chemicals which can be used to give the coating on the gold nanoparticles or any other nanoparticles. So number of phytochemicals are also there which are present in the compound or the extra can also be used as a reducing agent. Uh, After making some nanoparticles,
ऑडियो डिवाइस ऑन है क्या?
number of applications are there. For example, it's shown in the slide, antiviral, antifungal. So depending upon our applications, we have to use the method for the synthesis of this nanomaterial. So this shows, so we can say that number of applications are there of this material. So in this case, here we are going to see also some methods, green methods for synthesis of nanomaterials, nanoparticle from that. And as we know, silver oxide is also obtained or silver metallic silver nanoparticle obtained from the plant extract and have number of applications. This material or particle can be used in also washing machine for to sterilize and to remove the bacteria and to remove the odor. And for that purpose, this particle can be silver nanoparticle can be used. Nowadays also these particles can also be used in a they can particle can be embedded in a cotton bandage or also in a polymer gloves and embedded also in a apron. What is the polymer fabric apron? So only main aim is to remove the bacteria or to remove the odor from that fabrics. So this is a very important silver nanoparticle which is obtained from the green root of plant extract. Anyone can extract the plant medicinal plant extract and then by reduction we get these particles. So when we are dealing with the materials, so what is now in case of nanomaterial, two approaches are there. These are the two scientists. One is a Richard Feynman and second is a Jean Marie Lane. Both one is a physicist, second is one is a chemist, and both have received the Nobel Prize. And they have given the most important concept of getting the nanomaterial. And the first approach is given by Richard Feynman. What is top-down approach? And second is a bottom-up approach. And in case of top-down or bottom-up approach, what is now in case of top-down, we can get the nanoparticles start from the bulk material, slash it or cut it, and so that we can get the nanostructured material. And for this, they have given the concept. What is there are plenty of room at the bottom, and in case of bottom-up, they also given the concept there are plenty of room at the top. So meaning of is that one part can be divided into two part can also be divided into four part, so number of compartment can be made in that a small particle. So and because of this these particles have much more storage capacity as compared to any other silicon chip or any other materials. So even it is a small particle but now having greater capacity because it is possible to make as we require as part we can make in that. So that is why they have given the concept there are plenty of room at the bottom or there are plenty of room at the top. So these are the two main basic approaches for the nanoparticle synthesis. As we are discussing, that is the green approach. So here silica can also be used as a filler to enhance the properties of the some natural or synthetic rubber. And now in the Europe, scientists have made green tire in the Europe by using silica as a um, filler. And so after adding the filler silica, nanosilica in the rubber matrix or polymer matrix, what is then they have made such type of awesome tire and works. And main aim is that it is very durable. There is no some effects of the environmental. And, it enhances the adhesion and metallic reinforcement, and therefore it decreases the heat buildup. And because of this, is also known as green tire. And nowadays, the scientists are making such type of awesome tire, and in future also it will come in the market. So important factor for silica reinforcement when we add filler silica in the matrix, then there is a uniform dispersion. But initially there is a aggregation. and because of that uniform dispersion, this type of tire is possible. So this green tire, which is a silica sealing system, how it works is shown here. What are the three parts? So this is the grip. Here is shown silica sealing, and here is a weight grip, and here is a wear resistance. So because of this technology, they have made this type, such type of tire in the industry, tire industry, and now this technology is more useful for particularly for the two-wheelers or four-wheelers making the tire of this type. And this design, keeping in mind that that is the it when it uh, we can say that when it show the friction with the on the road, so there is no any damage on the material. So this is we can say that, so this is the new one, because in that silica have been used. Silica, nanosilica have enhanced the properties of this type of material. So simple rubber and any other materials can also be used, but when we add silica, we get this type of green material. And what is by using this uh, material, it is possible to make this type of silica sealing system and use for the green tire. So this is the green technology nowadays using in the uh, world are using, and in many laboratory the work is going on this part. Now there are, as we know, there are number of chemicals which are we found here. What is now bicycle? So many plastic materials, bags. So here this slide shows different type materials are there, but now people are throwing all this somewhere, and the waste of this material causes some problems. So we should not throw this. We have to collect and recycle it. So there are number of chemicals are there uh, which are we can use as a waste material. So by using this waste, we can make some other useful material. So by using a green technology, it's possible. So for that case, so green synthesis and processes are there, and some methods are there, normative framework or non-normative science. And here, main aim is to for this case is the uh, all these waste can be used for recycling. But for that, we should have to know there should be less energy and less hazard. As we know, there are 12 principles of green chemistry, and as we know, green chemistry is also known as a sustainable chemistry. And a backbone of sustainable chemistry is the what is the science and technology. As we know that, so in case of this uh, sustainable chemistry, chemistry and chemical process focus on to design the product and process to minimize or eliminate the use and generation of hazardous substances. So we can say that there should be a less waste, less energy, less hazard, and more renewable resources. So example of green chemistry, we can say that supercritical water oxidation, water reactions, dry media reaction are there. So bioengineering is also another part where we can use this part. It is the use of renewable raw material and eliminating the waste and avoiding use of toxic and hazardous reagent and solvent in the manufacture and applications of chemical product. So by using all these 12 principles of green chemistry, we can apply this to avoid all these hazardous material. And now to synthesize the any material, and for that there should be a less waste and energy. So synthesis of this less waste and less energy in the chemistry. Uh, so here one reaction is shown uh, in the C2 for the generation reaction of hazardous reactant, and it is more flexible, which is shown. And as we know, the Paul Anasto is the father of green chemistry. Here they proposes the green chemistry in 1998 along with the John Warner, and says that green chemistry is the sustainable chemistry, and green chemistry aim at making the chemistry more energy efficient and reducing the waste disposal and producing the innovative product with the less consumption and nature of the natural resources. And therefore, to achieve these organic waste, so many organic waste, renewable resources, organic waste, that is the orange turfers, covers are there, so many some fruits coatings are there, so many are there, and such type of waste we are throwing in the nature. So green chemistry play an important role in sustainable development, and sustainable development is a development that protect the environment and the world uh, uh, resources. And these 12 principles of green chemistry outlined within the work, and uh, it motivate academic and industrial scientists at the time and continue to guide green chemistry movement. So we should use all these waste, organic or some other waste, for the recycling or for some other purposes. And now for this purpose, tool here is a train, and here is a polyester PET structure is shown. Cotton contain elastin and polyurethane. All these are used time, and therefore challenges are there of organic chemists, which include discovery and development of new synthetic pathways using green chemistry tools like green solvent, green catalyst, and in organic synthesis, dry media synthesis and catalyst. All these are efficient for the synthesis. So, E factor, environmental factor, is also very important. We can calculate. So, there is a trend increase in the complex product in the textile also. So, which is shown here, the fabrics by using that. Also, trend is that plastic in and plastification. So, increase in volume and complexity. So, this is the homopolymer. This is the block polymer by using two monomers. This is the statistical copolymer, ABC trial, block polymers, and polymer with the functional groups. So, these are the functional groups. So, different types of polymers are there and can be used as a duroplastic or thermoplastic. So, now there is a need of such material. So there is a trend, and trend is also there. Some communication devices and digitalization, or we can say in case of electrification, all these materials e-waste are there. So we should use all these by using some green approaches. Trend is also there. Is shown that nowadays increasingly complex products in the communication in mobile phone. How what are the element out of 40 elements? Some elements are using here. That is the compounds, small organic molecule, polymers mixed with the molecular level. All these are the 40 elements have been shown. All these elements have been used in some purposes. So here is shown 1% of flame retardant, 4% of other, and here percent-wise ceramics, silver, zinc, nickel is shown. All these are the percentage shown can be used in these mobile devices. And here is shown what is the percentage here is shown also. So there is a trend to increase the complex product and which are useful, which can be used obtained by green methods. Trend is also there increasing the complex product which are used, that is the plastic and electronics useful in the cars. So this is the engineered thermoplastic solutions, and this is the car where we are making and using these different part in this material. So see, each and many, most of the part of this car have been made in electronics and plastics. So the trend is there, so increase the complex product to synthesize the product, and so that which can be useful, which is obtained from the green methods or green approach. So there is a role of chemist to minimize this waste, minimize the hazardous material, and design the products such that we can give minimum waste and minimum hazardous material. So we have to design. So there is a role of chemist. So while synthesizing, and after this waste we are obtaining can be recycling, then by using a particular resources we can obtain the we can use this material. So this is the process recycling. We by this, after recycling we can get the resources and use of these resources for some other purposes. So this is the slide show. So we can say there is a role of chemist. So someone also asks, why do we want to make the thing small? So we can say that we make the thing small because it should be a first smaller and faster and better, easy to handle and easy to carry from one place to other, and it can be used in different purposes. So that is why people need the things small. Now day by day the chips or the nano sizes are coming in the market, and therefore the storage capacity also is increasing day by day. So these nanomaterials are very useful and also in a smaller size. Introduction of this small size material, what is they show the change in the mechanical behavior, change in the surface area, change in the molecular recognition, and because of that, they show the changes in the properties. Here is also there is a new chemical process, there is a new bio applications. So the whole world is changing, and because of the change in the property, change in the structure, change in the applications, what is now because of introduction of this small material, so there is a changes in the properties in the nano region. So these are the properties we show the changes in the size, changes the properties, and these are the properties we show the changes in the size, show the change in properties. So this is the one slide we show how the size changes and show the change in properties. So as we know, generally the gold is in a, when it is in a bulk is a golden in color, but now when it is a smaller size, that is a size is 1 nanometer of gold, then it is a yellow or brown color. Here this is the yellow type, yellow color particles of gold. Here is a red color gold. Particle size is 20 nanometer. When particle size is 100 nanometer, the purple pink color is there. So gold also show the change in color if the particle size show the changes. So as the size changes, the properties of the material also show the changes. One there is a chemistry. As we know, size of the particle changes. So here is a gold particle which is smaller size. Here this is the gold particle which is larger size. When we heat it, what is then the reaction is carrying out? Then what is, when it is smaller size, then emit the carbon monoxide and carbon dioxide. But when it is on a larger size, then emit only the carbon monoxide. So this is the paper have been published by CNR Rao in the journal, European Journal, in 2002. So we can say that nano as the size changes, they show the change in chemistry. So material is same, but the emission of the gases are different. So we can say as the size changes, chemistry also changes. And now there are different methods of the synthesis, and these are some modern methods for the synthesis in addition to the green methods of synthesis of material. These are some more modern methods of the synthesis of nanomaterial. And in this case of synthesis of nanomaterial, some methods we are using in our laboratory. And this is the one sol gel method. And this process is a wet chemical technique used for the fabrication of the both glassy as well as ceramic material. In this process, use of either chemical solutions, that is known as the sol solution, or colloidal particles, also known as the sol for nano scale particles, and it give the network, that is the integrated network like gel. A gel type material is obtained. After drying the process, liquid phase is removed from the gel, and we get such type of material. So by using this sol gel process, these are the different steps have been shown, and finally we get the dense gel and we get the particles. So step by step, all the steps have been shown. By using, anyone can synthesize the material by using this sol gel process in the laboratory. And sol, as we know, sol is a liquid of colloidal solution. Gel can be described as solid or semi-solid, and sol can be converted into gel by cooling, and gel can be converted into sol by heating. So this is the one method of sol gel, and some more methods are also been given to synthesize the material. And solothermal synthesis method is a simple method, and this method is a typical wet chemical synthetic method using water or organic solvent as the reaction medium. And in this method, sealed vessel, that is autoclave, can be used, in which temperature we have to maintain 100 to 240 degrees Celsius. And after maintaining the temperature, the method, we get the nano size particles, and method is better than any other methods because simple to use, and generally the non-aqueous media is there. So the reaction can be carried out in the solothermal process in a non-aqueous and sometimes in aqueous media. So when it is carried out in aqueous media, then is a grain route. So one more method which is known as the hydrothermal method. And in case of hydrothermal method, again autoclave can be used, but this method include various techniques of crystallizing the substances from high temperature solution to the low temperature. And this method of synthesis generally used for single crystal synthesis and depends on the solubility of the material in hot water or under high pressure. The crystal growth is performed in an autoclave in which the nutrient is supplied along with the water. And therefore, temperature gradient is also a very important part. We have to maintain the temperature. Uh, the temperature can be used up to 300 Kelvin. So all these are the different methods for making the material. And after making this material, we should know some methods of characterization. And these are the same time and AFM, BET are used to characterize the synthesized material. This is the basic principle of the scanning electron microscopy, that when we pass the electron beam microscope, and what is done, it gives the images within a minute, and from the image we can say that what is the particle size and what should be the nature of the material can be decided. So here is shown what is the flow chart here. This is the uh, here we have to keep our sample of material, and then this is the arrangement. Electron beam passing through this, and what is after that, it pass through the specimen and give the signal, or this give the image scan, that electron beam scan it the material and give the image to the scanner, or to the attached to the what is the software is there, and give the image. From the image we can know the nature and the particle size, what type of, whether the nature is a different type of natures are there. We are comb like, star like, kite like, different types of natures are spherulites are obtained, and we can conclude, we can give the interpretation of getting the image of the same. But better match here, in short we can say that same give only the morphology of the surface of the material, but now more detailed morphology is obtained from the transmission electron microscopy. So here, these give the image of complete on this of the surface material, as well as the of the bulk of the material, because the electron beam, when we pass it, pass through the whole body of the particles and give the complete image. So what is the particle size on the surface? What is particle size inside the, or in the bulk of that material, inside the material, can also be known by using transmission electron microscopy. So this is the better method to know the size of the. This is another method which is known as atomic force magnetometer. This is the most useful method, and what is now here is the arrangement. This is the photo detector, laser beam is there. This is the metal surface, and what is there is a tip on AFM. So arrangement is there. This is the surface atom, and this is the tip of atoms. And what is now, when we touch this tip of this AFM to the material, it gives the particle size. So we can know what is the particle size in different places, different in by touching this tip. So this is the most accurate method, AFM, for this knowing the particle size and nature of the material. And now X-ray diffraction method is also there, and this Cherer formula is there. By using this Cherer formula, and from this plotting the graph, this graph is obtained from the X-ray, and from this obtaining the values, T can be calculated. It is the thickness of the crystalline, different particle size again, and some other parameters can also be obtained by using this drag angle shown here, and beta is the distance between these two peak here, and this is the theta is known, and by using this equation it is possible to know the and the particle size of the material. So all these methods are very useful. As we know, carbon is a very important material, and material, whether it is nano size, and the what is the CNT. Whenever we are discussing with the nanomaterial, there is a nanotechnology, and what is the carbon nanotubes. So carbon nanotubes only contain the carbon, and therefore these are the different forms of the carbon. One is a diamond, graphite, and these are the fullerenes in different size here, and graphene, and this is the nanotube, carbon nanotubes. So it all these are the allotropes of the carbon, and carbon nanotube can also be synthesized and are very useful to the society. So now there are two types of carbon nanotubes, and one is a single walled, and second is a multi-walled carbon nanotubes. So what is now carbon nanotubes are two types, and in this case, single walled and multi-walled, two types are there. Single walled is also useful, but multi-walled CNT are very much more useful. Single walled carbon nanotubes are the one-dimensional cylindrical shape, and other types of carbon and have a high surface area. Single wall carbon nanotubes are special class of carbon, which is also known as one-dimensional method, and consist of sheets of graphene and one atom thick. In addition to that, multi-wall carbon nanotubes are elongated cylindrical nano objects made up of sp2 hybridized carbon, and the diameter is 3 to 30 nanometer, and therefore they can grow several centimeter long. It is also the allotropes of carbon and have high aspect ratio. We can say that it is also called double or triple wall uh, carbon nanotubes. So single wall and double and triple walled carbon nanotubes are there, and which are also when we get added in some other materials, what is then they show the enhancement in the properties also. And here is shown these CNTs are three different types. One is armchair, shown here the structure, and another is a zigzag, shown the structure, and the third one is a chiral. This is the chiral type. So mainly there are three types of the carbon nanotubes: armchair, zigzag, and chiral. So detail about this is shown here. It depends upon this ratio A1 and this ratio A2. Depending upon A1 and A2 and the uh, uh, what is the angle also, there are the three different types are there. So mainly there are three types of these basic types. These CNTs can be made by using these three different methods. In the laboratory, it is possible to synthesize. We should have the apparatus. So by using electric arc discharge in our laboratory, the CVD method, chemical deposition method, laser ablation method is also there, which is a very simple method for CNT. And this is the method where we can use this CVD method for the synthesis of nanomaterial. And now here the arrangement, after making this type of arrangement, here is a reservoir. We should have to set the parameters. In the reservoir, ferrocene dissolved benzene is there. Benzene toluene can also be used, xylene, and then flow rate is shown here, and solution flow rate is 3 ml per minute. Carrier gases of we have to pass 50 ml per minute. Here is a carrier gas argon, and atmospheric pressure we have to maintain. And after from the reservoir solution comes here, here is a K type of thermocouple is there, and after passing the solution from the reservoir, there is a interaction, and here is a in a thermocouple, and we get this type of material because of this is here striking this solution to the thermocouple, and finally we get some exhaust gas coming out from this exhaust, and we get here the material which is the CNTs. So by using this CVD method, is it possible to synthesize the CNTs? And so this CVD is the most widely used method and for the CNT. And for this purpose, metal nanoparticles are mixed with the catalyst like magnesium oxide, aluminum oxide, or some other oxide to increase the surface area, and catalytic reaction of carbon can also be carried out. So the procedure can be optimized to obtain uniform layer of the CNT. So we have to set the parameters so that we can get the uniform layer of the CNTs. So these are the application of CNTs. Once we set the parameter and once we get the CNTs, what is the application? So CNTs are much more useful. We can also make the nanocomposites. Film can also be made, can be used in a biotechnology for different purposes: energy storage, water filter, transistor, screen, fuel environment. So these are the paper packaging. So different applications of these materials are shown here in this slide of CNT. So CNT synthesis and the applications are very, very useful in the society. And now these CNTs are useful for to make the our screen television flat, and because of this uh, PC or the television, uh, we can make it is a flat, or sometime it may be a foldable, ultra thin. So this foldable PC we can fold also into three, and we can carry from one place to another. It is very lightweight and can be made because it is made by using the CNTs, carbon nanotubes, and because of that it is lightweight, it is strong, and also the screen may be a flat or can be folded as we require. So in the next time, what is now, it may come, this type of screen may come in the market. LED plasma TV came in the market. Now CNT, what is the site in the USA? They developed the biggest computer chip using the CNTs, and instead of silicon chip, instead of some any other materials, what is, they have made this type of chip, and so because of that, this is the uh, uh, paper which is published in Nature in 2019. So in the MIT USA, they have made the world this computer chip shown here in this slide. These CNTs are also useful for, as a racket in the racket for tennis racket or for any for and because of this, by using this, the body of this racket can be made by using these CNTs, and because of that, it is very durable, it is very strong, and also lightweight. It can also be used in the body of this bicycle, and made the main body of this bicycle made with the CNTs. So for both the purpose, because of this using this material as a CNT in the in this body of the bicycle, it is again very lightweight and can be tough and strong. And this material can also be very useful for the soldiers, and this beneficial for the soldier, and shows that there is a possibility of manipulation of light to make the soldier invisible, and also it suit for different environment. So some sensors can also be there. Because of that, they can know what is the location of enemy, so they can find, and they can also be invisible. So different properties of the nano fabrics are there. So by using this CNT in the fabrics, nano fabrics are useful to the soldier. So radio communication can also be possible directly into the uniform fabric. So all these are the important properties of this nano fabric, and this is the nano CNTs which is used in the fabric, so which is known as the nano fabric, useful for the soldier, and it also provides chemical and biological protection. So is there any war, chemical or biological? So it also show the soldier can get the protection from that. Uh, I know there are different types of application of this carbon nanotube, as we have seen in the badminton racket, TV screen, and also some nowadays this material also using in a signal. So red, yellow, and the green signals are there in the square. So for these electronic junctions, these for this material nowadays they are using, and because of that they are very what is that, they emit the light very strong and bright, and so and cheaper also. This material nowadays using in these signals. Uh, Also, one property that we have studied, one is the that CNT, CNT means carbon nanotubes, single wall and multi wall. We have mixed with the cement, Portland cement, and see the nature obtained. This is the absence of nature of the same image. Absence of CNT. What is the nature here? With the presence of single wall and with the presence of the multi wall. So it is observed that 30% efficiency increases by the addition of our multi-words carbon nanotubes. So, and 10% by using single word. So what is now? So in addition to the Portland cement is strong and other properties are there, but when we add this much, the efficiency, durability, and the toughness increases by 30% of this Portland cement by the use of CNT, single word, and mostly the multi-word. So this is already been tested. And nano gold, as we have seen, can be obtained from the plant extract, can be synthesized in the laboratory by using a green route for the sustainable development. And now this is the wonderful material, and can be used in different field, medical field, science and technology. And because they have, if we change the properties of this size of the material, they show the changes in the properties. As we know, this gold, nano gold can be used as a catalyst. Because smaller size is there, because already it is a smaller size, and surface area, because of the smaller size, surface area of these particles is a very high or larger, and therefore they show higher catalytic power. So it can be used catalyst because of the larger surface area, because it is a smaller in size. And again now, as we know, when this nano gold is in a face center, when it is in normal. But when the size is smaller, what is then icosahedrate structure is there. In the bulk gold have the phase center cubic structure, but when the particle size is nano, then what is the it shows the icosahedrate structure. So as the size changes, we can see that they show the change in the structure of the material. One more property is that this gold can also be used as a catalyst in different reactions. Here is shown some reactions: partial oxidation reaction of propylene to propylene oxide, carbon monoxide oxidation at temperature of low 70 degree, reduction of nitric oxide, and also some other. So this nanogold can also be used as a catalyst in different chemical reactions. This one of the important use of this nanogold is to anti-angiogenic therapy. So for drug delivery, this can also be useful. And as we know that this nanomedicine can be injected to the body of the patient. And so here is shown tools for drug delivery. So this is the particle of nano drug and injected to the body of the patient. And what is now after injection to the body of the patient, then it repair the part, infected part, and get digested. Here is a single drug loaded nano drug. Here multi nano drug can also be loaded for different purpose, and it repair the part, and what is then get digested because it is a DNA base. So for this important tool for drug delivery, and therefore this material nano drugs are very useful material. In addition to that, there are some also magnetic properties, and uh, these material, nano size material, can also be used to store magnetic material, and better than the other devices or other materials like silicon and some other materials, and can be used in a cellular phone, credit card, and microwave devices. It is also possible to make the nano size, zero dimensional, one dimensional, two dimensional materials, that is composite material, nano composite material. And for that we can mix metal metal or metal ceramic or ceramic ceramic. And because of that, polymer based composite can also be made: polymer, ceramic, inorganic, organic polymer, inorganic, organic hybrid, biopolymers, and cold shell. Different types of composite preparation is possible, and so this is the way that it is possible to uh, different types of uh, uh, nano scale dimension material can be made, which is known as the nano composite material. Uh, this is the car where this material can be useful, and sensors. So here is shown some nanocomposite. Uh, After making the nanocomposite, they can be used in a solar cells, fire retardation, food packaging, biodegradable polymer nanocomposites, water purification, and some other field. And here, most of the part of this car have been made by using these nanocomposite materials. So by using metal oxide, nanofiller can be introduced, and it is possible that material nanocomposite can be used for different part of this car. So nanocomposites are very useful material. One more material is shown, that is known as the superconductivity, is the one other property. And as we know, what is superconductivity? Is the set of physical properties observed in the certain material where electrical resistance vanishes and magnetic flux field are expelled from the material. So in this case, as material where electrical resistance vanish and magnetic flux field are expelled from the material, and such material exhibiting the properties which is known as the superconductor. So here is shown graph between the resistance temperature. So here is a metal good conductor. Semiconductor here is shown, and this is the critical temperature. But now beyond the metal, after this, here is a superconductor. So here resistance is zero. Uh, Here clearly shows at this TC means critical temperature where the resistance is zero. So here is the shown how semiconductor metal, and here is the superconductor. So this graph shows clearly zero electrical resistance superconductor means. So here is a major effect where here the uh, rays are passing through the material, but here in the second B, the particles are not passing the material but through the vacuum. So expel all the magnetic flux from their interior, so are forced out of magnetic field. So this is the major effect shown. And this Meissner shown that superconductor can float. Superconductors can float or levitate above the magnetic field. Here is the material. This is the magnet, and it float, not touching. And by using this technique, scientists in the Japan have made the frictionless train, which is known as the bulletproof train. And this works on the magnetic field, and there is no. This is the superconductor which is used this phenomena for this bulletproof train, and there is a superconductor that float or levitate the magnetic field, and so speed is much more as compared to other uh, materials. So by using this concept and by using this material, scientists get success of making such a bulletproof train. Now niobium titanium material composite can also be used to take the MRI. For that case, superconductive material can be used. This material can be used as a superconductive, and the temperature we should have to maintain 9.4 degree. And this temperature, it take this material can be useful, and therefore this is the composite material. Nano composite material used for to take the MRI of the patients. And this is the area where nanotechnology can be used. So different areas are there: fuel cells, sensors, memory storage, devices, paint, cosmetics. All these are the different fields where we can use this technology. Now, as we know, Thomas Edison was the first to introduce the incandescent bulb, and now different bulbs are there, LED bulbs are there. So here is a red and infrared, aluminum, gallium, arsenic. Gallium, arsenic for red, orange, yellow color they are emitting. Gallium, nitrogen, green. So these are the different composite material where they emit the different colors. And nowadays LEDs are more useful in the uh, in place of the incandescent bulbs. So here is shown comparison. So condenser bulb, here is a candle, here is a bulb where tungsten filament can be used. Here is a CFL bulb, and here is a LED bulbs. So now LED bulbs, how these LED TV also came in the market, and this concept is used. What is the concept of OLED also came, organic light emitting diodes. So light is passing, they are giving, but for that metallic cathode is here, anode is here, and cathode between these two, what is there is a organic material. This red color is the organic material, and uh, after making such type of arrangement, what is now they emit organic materials are there, light emitter. They give different types of color: yellow, blue, green, red, like that. And therefore the TV also came. This material also used in devices, in television devices known as a OLED. So OLED works, and because of OLED, the uh, properties of this device is it is a brighter and very clear image, and also thinner and lighter in the weight, and low powered, can be printed on the various surfaces. So these are the properties of this OLED, and because of that, very useful material nowadays. Uh, Also the miracle is there, and lithium powered heart is also been made, and this is the miracle. What is the cardiac pacemaker which operated on the battery? And now we can say that Robert West power this type of tiny magnet microstimulator device and jump start broken down connection in conditions like Parkinson, epilepsy, and incontinence. And this the lifespan of this artificial uh, uh, operating on battery powered heart is 2 years and maximum up to 10 years. So this is the miracle of the science, uh, which is made by using the lithium battery, works on this lithium battery. So this is the miracle of the science and technology. Now some part is left, and what is the impact of the this nano size material on the some part. That is, the first part is the material, second is healthcare, and for technology and for environment. So are very useful material. So in case of material stain resistant cloth, if we use such type of nano fabric in the stain resistant cloth or nano fiber, it is easy to remove the color spot or any other dirt. So in the near future, may come the fabrics may come by using this nanofiber, and uh, so then it is easy to remove the stain, easy to remove from the fabric the colored spot or some any other dirt. So near future, such type of material may come or fabrics may come in the market. So we can say these are the material which is a stain resistant cloth, where the uh, nano uh, nano size material are using in the fabrics. So nanofibers are the material, and a 10 nanometer carbon research bond with the cotton is there, and like a pitch fuse, many liquid roll off. So it is possible, and it refuses any stain, and it is easy to remove also. So the nano fabrics are very useful in the society, for the society. This is now another important use of this nano material paint that doesn't chip. That is means we can also make the protective nano paint. Nano paint contains some nano material, and when we paint on the car, what are the changes it can take place? So it may be a water and dirt repellent, and scratches can also be removed easily. Show the brighter color, enhance the gloss, and also in the near future scientists are trying that they are changing the color, so they are using the such type of material that so that the car can show the change, like a material show the change, yellow, blue, green, like that. So in future also such type of car may show the changes in the color. Another important property is that material can be used in a paint. And as we know, nano paint, when pasted on the tall buildings, are used, the tallest building of the world is nowadays in Dubai, this Burj Khalifa. So on this also, they have used this type of nano paint. Because of that, yeah, the surface of the building do not get damaged. And because reason is that in nano paint, some materials are there which titanium dioxide mainly, which break down the organic and inorganic pollutant, and also remove the formaldehyde, and therefore uh, they also break down the particle like formaldehyde, and therefore they protect the surface of the buildings. And because of that, TiO2 play an important role for this purpose. And we can these material are useful to clean the environment, to we can say that what is the to reduce the pollution. So to get clean air and environment, for this purpose these nano paint are very useful for reducing the pollution. Another important use that in the future also, and nowadays nano solar cells are used as a small device. And we have also made one material of nano size, nano cell or cells. Uh, in the villages, what is now, there is some problems of electricity and other. So it is possible on the solar cell, we can transfer the water from one place to other. So this is also now is possible. Now in the future also, uh, if we use nano solar cell on the bus or on the some two-wheelers or on the car of the roof, it absorbs the amount of energy and can run on the solar. So this is the here is the electrode, one electrode, another electrode, anode and cathode. Between these two, nano rod is there. Here is the nano rod, and on the one side is the glass. It absorbs the sunlight from the sunlight. And what is now, uh, they are storing this energy, solar energy, and what is now, they this energy can be used for uh, different purposes. So nano solar cells may come in the market. Nowadays, scientists are doing research on this part. And in near future, there is no need of petrol or electricity to drive the car and some vehicles. So we can use our solar cells for that purpose. And this is the another property DVD and is shown. Initially, there was the CD. It can store some part of the material, but what is now in DVD, some more storage capacity is there. After that, silicon chips came, and silicon chips store many much more uh, having the storage capacity. But after silicon now, when the nanomaterial came in the market, what is now nanomaterial have much more storage. We can say that 1 lakh times greater capacity as compared to silicon chips. So this day by day storage capacity of chips because of the using nano size in the mobile chips or in any other computer chips or whatever we are using, in that the storage capacity are day by day increasing. So this is the magic. This is the use of this material. These are the field where we can use this material again, biomaterial in medical sciences. And as we know, challenges are there for the academic institutions and the academicians. And our APJ Abdul Kalam in December 2006 says that creativity leads to the thinking, and thinking provide the knowledge, and knowledge make you great. So by using this, anyone can do the research in new field or in this field. So one can also make the nano robot. And so some challenges are there. They can make a smallest machine, they can make smallest robot, they can make some other. By using this technology, one can get when can do research in that field and get uh, take a challenge and make another now innovative work or innovative some things are there. So according to this, we can do some research in that field or in by using this material, and uh, we can produce we can give to the society. So here a smart person solve a problem, a wise person avoid it. This is attributed by the Albert Einstein. So small persons are there but solve the problems, and wise persons avoid it. So this is the important part thing which is given by Albert Einstein. So in the last in the summary, I can say that so this is the another branch, uh, material science, where we can synthesize the different types of material by using different methods, by using a green root or green synthesis method, and some other modern methods of synthesis by using of aqueous media. And these material after that characterizing, and after characterizing we can use a number of applications we have seen, where we can use the material. According to that, we have to apply for the synthesis. So and also challenges are there for making this material useful to the society. So this is an important topic where we can reduce the pollution, we can reduce the waste and some other part. So we can say that green chemistry for sustainable development, we can apply this concept and our principle of green chemistry. So thank you to all the participants here. And if anyone having any doubt, you can ask the question, your doubt. Thank you, madam. Hello, thank you, madam.
please. And close everything. So thank you so much, Dr. Kule, and I really hope that you are going to.
Thank you, madam.
Yeah. It's pleasure knowing you, and we are very happy that you joined us. Thank you so much. So now let me introduce you our second speaker to you. His name is Dr. Actually, Dr. Sharma is working as an associate professor in Raj Rishi Government Hospital. He is a renowned author of several textbooks in the field of plant and environmental science. He is having more than 25 years of experience in teaching botany, undergraduate, postgraduate, as well as academic students of the different government colleges from Rajasthan, where he is being hosted. He has participated in various international and national conferences in related fields and completed successfully many projects on environmental biology in collaboration with the Department of Environment, Government of India. Dr. Lakshmidhar Sharma has a Doctor of Compassion and Love for the Nature and a poetic heart, and has written and edited as many as 6 books on Hindi poetry. That is added as one of his Dr. Sharma, artist from International State. Earlier, he was awarded gold medal by the Common Arts University in 1990, and Jawaharlal Nehru Memorial membership in the year 1990. That's the amazing thing. Thank you so much, Dr. Sharma, for joining us. The government gets to respect and let's call upon Dr. Sharma for his presentation. Dr. Sharma, please go ahead.
Thank you, Dr. Mamta Sharma. And warm greetings, hello and welcome, and very good morning to our respected Dr. Mukam Singh, Organizing Secretary Dr. Mamta Sharma, our delegates and participants. First of all, I offer a sincere word of apology to present before you myself, as I was not thoroughly prepared for this presentation, as we are heavily engaged in preparing SSR for forthcoming land inspection. We are trying to submit it at our earliest, and it was an order by organizing secretary to present me here as a pillar between the two speakers, Dr. Vasudev and Dr. Kushi. So please be thank you. मैं अपना प्रेजेंटेशन जो इकोलॉजिकल रिस्टोरेशन है वो शुरू करने से पहले मैं कुछ सामान्य बातें से करना चाहता हूँ शेयर। 1946 में जब हमारे पटवानिया ने पंडित जवाहरलाल नेहरू को यहाँ का हिंदुस्तान का कर दिया और उसके बाद हमें आजादी मिली अगस्त 15, 1947। इस बीच में तो जो हमारे प्रथम प्रधानमंत्री पंडित नेहरू और ब्रिटानिया की जो हुकूमत थी, इनके बीच में इस स्थिति में तय किया गया कि कुछ जो एसेट्स हमारे इंग्लैंड चले गए हैं, ब्रिटिशर्स जो ले गए हैं, उन्हें किस तरह से बाद में कॉमनवेल्थ केस चले और इसका कुछ पोर्शन हमें वापस लेना तय हुआ, कुछ कैश में और ज्यादातर टेक्नोलॉजिकल आइडियाज हमें जो उसके इम्प्लीमेंटेशन की फॉर्म में ये हमें लौटाया। तो अगले 80s में ये कंसेप्ट रिस्टोरेशन इंडिया में आया और एक ब्रिटिश फर्म ने इंडिया के कुछ खास हिस्सों को कुछ पार्ट्स को चिन्हित किया और यहाँ पर उन्होंने बेसलाइन सर्वे कराया। XZ हिंदुस्तान जिंक लिमिटेड ये वाला जो एरिया है उधरपुर, रामपुर, गुजरात, चित्तौड़गढ़ तक फैला हुआ है। इस एरिया का एक बेसलाइन सर्वे हुआ और मैं इस टीम का एक पार्ट था। एक पूरी टीम थी हमारे साथ, उसमें जियोग्राफर्स थे, सोशियोलॉजी के विद्वान थे, जूलॉजिस्ट थे और ऑर्निथोलॉजिस्ट थे, बॉटनिस्ट थे, और हम लोगों ने बेसलाइन सर्वे की। बेसलाइन सर्वे जो ब्रिटिश कंपनी ने कराया कि 50 साल पहले क्या हालत रही होगी इस एरिया में एनवायरमेंट की, प्रेजेंट पोजीशन क्या है, और अगले 50 सालों में अगर डिस्ट्रक्शन इसी तरह से चलता रहा तो क्या स्थिति हो जाएगी। और बाद में ये सारी रिपोर्ट्स जो कि हमारी बेटी की अनुबंध के तहत बने थे, सारे रिपोर्ट्स हमें ब्रिटेन की गवर्नमेंट को देनी पड़ी। उन्होंने उसे अपनी तरह से मॉडिफाई करके इंडियन गवर्नमेंट को भेजा और वो पॉलिसी मेकिंग में काम आया। तो एक बात ये हुई, हमारे यहाँ जो कंसेप्ट है रिस्टोरेशन का, अगर इसका मीनिंग हम देखेंगे तो ये हीलिंग है, और कंजर्वेशन से थोड़ा सा डिफर करता है। कंजर्वेशन प्रोटेक्ट करता है, आज की जो एनवायरमेंटल कंडीशंस है उसे हमें कंजर्व करना है, संरक्षित करना है, जितना भी हमारे पास है उसको हमें प्रिजर्व करना है। और रिस्टोरेशन कहता है कि हम वापस से पहले की कंडीशन में लौट आए। इंडिया में कंसेप्ट थोड़ा सा और लेट शुरू होता है, और मैं बात करना चाहूंगा नैनीताल वैली प्रोजेक्ट की, और जो कि गुजरात, मध्य प्रदेश, महाराष्ट्र राजस्थान यहाँ तक ये फैला हुआ है। और चूंकि ये अभी एक पॉलिटिकल इशू है, कई सालों से है, कई दशकों से है, और लीगल मैटर्स पेंडिंग है बिफोर ऑनरेबल सुप्रीम कोर्ट एंड ऑनरेबल हाई कोर्ट। तो बात करने के लिए अपने पास नहीं है, मैं इस पर ज्यादा बोलना नहीं चाहता। लेकिन यहाँ से रिस्टोरेशन शुरू हुआ और यह तय किया गया कि जो जमीन इस डैम के सरदार सरोवर डैम के बनाने में काम आएगी, यहाँ से जो यहाँ के स्थापित किया गया, यहाँ पे ट्रीज दिए गए, और ट्रीज के साथ जो मोना जो बर्ड्स थे, यानी कुल मिलाकर एक पूरा इकोसिस्टम यहाँ से हटा दिया गया। अब इन्होंने कहा कि हम यहाँ रिस्टोरेशन टेक्निक लगाएंगे और इसी इकोसिस्टम को वापस रिवाइव करते, और ये थोड़ा सा कम मुश्किल होती है क्या कि हमारे ब्यूरोक्रेट्स और उनके साथ कुछ इंजीनियर्स इस टीम में थे जो इस इकोसिस्टम को कर रहे थे, और उनके सामने एक सीधा सा कंसेप्ट ये था कि भाई पेड़ कटे हैं, पेड़ लगा दिए, कौन से लगाएंगे, कौन सी स्पीशीज होगी, ये ज्यादा मैटर नहीं करता। पेड़ लगाएंगे तो वहाँ परिंदे आएंगे, जानवर आएंगे, और एक इकोसिस्टम वापस बनेगा। लेकिन दुर्भाग्य से ऐसा नहीं हुआ। हम जानते हैं कि जब कभी भी ये मशीन ट्री प्लांटेशन की तरफ जाती है तो फास्ट ग्रोइंग ट्रीज को इस्तेमाल करते हैं, और हम जानते हैं खिजड़ी ऐसी स्पीशीज यहाँ पर लगाई जाती है, और एक इकोसिस्टम जो कि हजारों लाखों साल में डेवलप होता है, आप उसे 5 से 10 साल के अंदर में डेवलप कर दें, ऐसा कतई पॉसिबल नहीं है। तो कुल मिलाकर रिस्टोरेशन के नाम पर हमारे सामने आज हमारे कंट्री में भी, और मैं ग्लोबल में भी बात करता हूँ, वैश्विक स्तर पर भी दो तरह की पिक्चर्स हैं। एक मॉडर्न आर्ट है, बड़ा खूबसूरत सा बना हुआ है, और इसकी जो समझ है वो उसे उस हिसाब से देख सकता है, ये मॉडर्न आर्ट की विशेषता है। और दूसरी एक पिक्चर जो ज्यादा भयावह है वो है जैसे फोटोग्राफ का नेगेटिव होता है, आपको कुछ समझ नहीं आ रहा, कहीं कोई दिशा नहीं है, तो जो हमें दिखाया जाता है और जो एक्चुअली धरातल पर काम हुआ है इसमें काफी फर्क है। और मैं कुछ लाइन्स के साथ, पंक्तियों के साथ इस बात को बताने की कोशिश करता हूँ। इस समंदर ये तेरी खामोशियां कुछ और कहती हैं, समंदर ये तेरी खामोशियां कुछ और कहती हैं, मगर साहिल पे डूबी हुई कश्तियां कुछ और कहती हैं। और यूं तो देखे हैं मेरी आंखों ने मंजर कुछ और, यूं तो देखे हैं मेरी आंखों ने मंजर कुछ और, मगर अखबार की सुर्खियां कुछ और। So let's start our So it's ecological restoration. It's need of ours to save like the matter our mother Earth. And it is the term restoration emerged as separate field of ecology early 1980s. It is scientific study supporting the practice of ecological restoration, which is the practice of renewing and restoring degraded, damaged, or destroyed ecosystem and habitats in the environment by active human intervention and action. The term restoration ecology is therefore commonly used for the academic study of the process, whereas the term ecological restoration is commonly used for the actual project or process by the restoration practitioners. The Society for Ecological Restoration defined it as an intentional activity that initiates or accelerates the recovery of an ecosystem, respect to its health, integrity, and sustainability. The practice of ecological restoration includes wide scope of projects such as erosion control, deforestation, usage of genetically local native species, removal of non-native species and weeds, revegetation of distributed areas, and daylighting schemes, reproduction of native species, as well as habitat and raise improvement food species. You mentioned as a biologist states here is the means to end the great extinction part of the next century, I believe, be the era of restoration in ecology. The land managers and lay people and stewards have been practicing ecological restoration or ecological management for many hundreds, if not thousands of years. Yet the scientific field of restoration ecology was not fully identified and quite until the late 1980s by John Eber and William Jordan. When they were at the University of Wisconsin Medicine, they held the first international meetings on this topic in medicine, during which attendees visited the University of this Wisconsin University. And the oldest restoration ecology project made famous by Professor Andrew Leopold. The study of restoration ecology has only become a robust and independent scientific discipline over the last 2 decades, and the commercial application of this restoration have tremendously increased. Now, what's the need of restoration? There is consensus in the scientific community that the current environmental degradation and destruction of many of the Earth's biota is considerable and is taking place on a catastrophically short time scale. Estimates of the current extinction rate is 1,000 that 10,000 times more than the normal rate. For many people, biological diversity or biodiversity is considered has an intrinsic value that humans have a responsibility towards other living things and an obligation to future generation. On a more anthropocentric level, natural ecosystem provides human society with food, fuel, timber, and fodder for their animals. And fundamentally, ecosystem services involve the purification of air, water, detoxification and decomposition of waste, regulation of climate, regeneration of soil fertility, and pollination of crops. Such processes have been estimated to be worth billions of dollars annually. Now, we can differentiate these two: conservation biology and restoration ecology. The restoration ecology will be viewed as a sub-discipline of conservation biology, the scientific study of how to protect and restore biodiversity, and restoration a part of preserving conservation. Conservation versus restoration. There is many differences between the two. The fundamental differences between these two is effort is analogous to difference between disease prevention and treatment. Conservation aims to maintain and protect existing habitat and biodiversity, whereas restoration aims to reverse existing environmental degradation and population declines. Targeted human intervention is used to promote habitat, biodiversity recovery, and associated gains. The possibility of restoration, however, does not provide an excuse for converting extremely valuable pristine habitat into other uses as medicine. It is better to prevent than to treat. Treatment is generally less and more expensive than prevention, and treatment cannot always restore the condition before the injury. Some habitat and biodiversity losses are permanent. Now, what should our focus? Though restoration ecologists and other conservation biologists generally agree that habitat is the most important locus of biodiversity protection. The disciplines themselves have different focuses. Conservation biology, as an academic discipline, is rooted in population biology. Because of that, it is generally organized at the genetic level, looking at specific species population, that is our endangered species. Restoration ecology is organized at the community level, looking at specific ecosystem. Because it is organized by the species, conservation biology often emphasizes vertebrate animals because of their salience and popularity, whereas restoration ecology emphasizes plants because of their importance within an ecosystem. Ecosystem restoration is botanically based, since soils define the foundation of any functional terrestrial system. The restoration ecology ecosystem level focus also results in greater emphasis on the role of soil, physical, and microbial process. Now, what are modes of inquiry? What is the theoretical foundation for restoration? These are some parameters or some factors. First one is disturbance. Disturbance is a change of environmental conditions which interferes with the functioning of a biological system. Disturbance at a variety of spatial and temporal scales is a natural and even essential component of many communities. Humans have had limited natural impacts on ecosystem for as long as humans have existed. However, the severity and scope of our influence has accelerated in the last few centuries. Understanding and minimizing the differences between modern, anthropogenic, and natural disturbances is crucial to restore restoration ecology. For example, new forestry techniques that better imitate historical disturbances are now being implemented. In addition, restoring a fully sustainable ecosystem often involves studying and attempting to restore a natural disturbance. For example, which is very relevant to our nation, like in Uttarakhand and all others. Now, second factor is succession. The ecological succession is the process by which the component species of a community changes over a time period. Following a disturbance, an ecosystem generally progresses from a simple level of organization, that is few dominant species, to a more complex community. It means many independent or new species over few generations. Depending on the severity of the disturbances, restoration often consists of initiating, assisting, or accelerating ecological successional processes. In many ecosystems, communities tend to recover following mild to moderate natural and anthropogenic disturbances. Restoration in these systems involves hastening and natural successional trajectories. However, a system that has experienced a more severe disturbance, be it physical or chemical alteration of the environment, may require intensive restorative efforts to recreate environmental conditions that favor natural succession process. This This ability to recover is called resilience in the biological scale most. Now, fragmentation is another factor. Habitat fragmentation is the emergence of spatial discontinuities in a biological system through land use changes, for instance, agriculture and natural disturbance. Ecosystem are broken up into smaller parts, and small fragments of habitat can support only small population, and small populations are more vulnerable to extinction. Furthermore, fragmentation ecosystem decreases interior habitat. Habitat along the edge of the fragment has a different range of environmental conditions and therefore supports different species than the interior. Fragmentation effectively reduces interior habitat and may lead to extension of those species which require interior habitat. So, projects can increase the effective size of the habitat by simply clearing area or by planting habitat corridors that link and fill in the gap between two isolated fragments. The next factor is ecosystem function. The functioning of ecosystem is described with the fundamental process of natural system, including nutrient cycle and energy fluxes. These processes are the most basic and essential components of ecosystem, and understanding of the full complexity and intricacies of these cycles is necessary to address any ecological process that may be degraded. A functional ecosystem that is completely self-perpetuating, it means no management is required for them, is the ultimate goal of restorative efforts, since these ecosystem functions are emergent properties of the system as a whole. Monitoring and management are crucial for the long-term stability of an ecosystem. Next parameter is evolving new concepts. Because its highly physical nature of expression ecology is an ideal testing ground for an emerging communities ecological principles. Likewise, there are emerging concept of inventing new and successful restoration technologies, performance standards, timeframes, local genetics, and society's relationship to the restoration technology, and new ethical and religious possibilities as future topics of the discussion, debates, and this kind of seminars or webinars. Now, assembly is next parameter. The community assembly is a framework that can unify virtually all of community ecology under a single conceptual umbrella. And community assembly attempts to explain the aspects of the environmentally similar sites with different assemblages of species. It assumes that species have similar niche requirements so that community formation is a product of random fluctuations from a common species pool. Essentially, if all species are fairly ecologically equivalent, then random variation in colonization, migration, and extinction rates between species drive differences in species composition between sites and comparable environmental conditions. Now, the next is stable states. And alternative stable states are discrete species compositional possibilities that may exist within a community according to assembly their choice. Differences in species colonization, interspecific interactions, and community establishment may result in distinct community species equilibria. A community has numerous possible composition equilibria that are dependent on initial assembly. That is, random fluctuation lead to a particular initial community assembly, which affects successional trajectories and the eventual species composition equilibrium. Now, another factor is ontogeny. The ecology of factor ontogeny is the study of how ecological relationships change over the lifetime of an individual. Organisms require require different environmental conditions during different stages of their life cycle for mobile organisms, that is plants. The conditions necessary for generations and establishment may be different from those of the adult stage. As an ecosystem, it is altered by anthropogenic process. The range of environmental variables may also be altered. A degraded ecosystem may not include the environmental conditions necessary for a particular stage of an organism's development. If a self-sustaining functional ecosystem must contain environmental conditions for the perpetual reproduction of its species, restorative efforts must address the needs of organisms throughout their development. Now, spike heterogeneity is effect on community heterogeneity. Especially heterogeneity of resources can influence plant community composition, diversity, and assembly trajectory. Soil resources in a tall grasses prairies restoration project, few scientists found increasing resource heterogeneity and which on its own while insufficient to ensure species diversity in situation where one species predominant across the range of resource level. Now, invasion, competitive dominance, and the resource use. The dynamics of invasive species may depend on their abilities to compete for resource and exploit disturbance relatively to the abilities of native species. Then, successional trajectory progress along a desired successional pathway may be difficult if multiple stable states exist. Looking over 40 years of wetland restoration data, uh, the scientists argue that unexpected and undesired vegetation stabilizes may indicate that environmental conditions are not suitable for targeted communities. Succession may move in unpredicted directions, but considering environmental conditions within a narrow range may be in the possible successional trajectories and increase the likelihood of a desired outcome. Now, to summarize this presentation, even though an ecosystem may not be returned to its original state, this Ananda Valley project के संबंध में presentation की प्रारंभ में निकल गया था. Even though an ecosystem may not be returned to its original state, the functions of the ecosystem, especially ones that provide service to us, may be more valuable than its current configuration. And one reason to consider ecosystem restoration, afforestation involves replanting forests, which remove carbon dioxide from the air. Carbon dioxide is a leading cause of global warming, and capturing it would help alleviate climate change. Another example of common driver of restoration project in the United States is the legal framework of the Clean Water Act, which often requires mitigation for damage, inflicted and ecosystem, aquatic system by development or other activities. Now, what are the challenges in doing so? Some view ecosystem restoration as impractical in part because it sometimes fails. And few scientists all over the world point out that many times uncertainty that is about ecosystem functions, species relationships, and such is not addressed, and that the time scales set up for complete restoration are unreasonably short. In order, in other cases, an ecosystem may be so degraded that abandonment allow a preserved ecosystem to recover on its own. Maybe the wisest cheapest option as it is presumed by Hall 2006. Local communities sometimes object to restoration that include the introduction of large predators or plants that require disturbances, regimes such as regular fires. High economic costs can also be perceived as a negative impact of the restoration process. Public opinion is also very important in the feasibility of the restoration. If the public believes that the cost of restoration outweigh the benefits, they will not support it. In this case, people might be ready to leave this ecosystem to recover on its own, which can sometimes occur relatively quickly. और राजस्थान के और गुजरात के जो एग्जांपल मैंने आपको दिए, यहाँ पर एग्जैक्टली यही हुआ है। जब वो रिस्टोर नहीं कर पाए, तो वहाँ के जो लोकल हैबिटेट्स थे, उन्होंने वो जगह छोड़ दी और अपने इकोसिस्टम को अपने आगे के भरोसे डेवलप होने के लिए छोड़ दिया। Many failures have occurred in past restoration projects many times because clear goals were not set out as the aim of the restoration. Exactly, सरदार सरोवर डैम के प्रोजेक्ट में हमारे पास उस वक्त क्योंकि इंजीनियर्स थे, डेवलपर्स थे, क्लियर गोल इसको इकोसिस्टम को रिस्टोर करने के लिए नहीं थी. So this maybe because as Peter Edwards says, people may not always know how to manage natural ecosystem effectively. Also, many assumptions are made about mines of restoration, such as the carbon copy, where a restoration plant which worked in one particular area is applied to another area with the same result expected, but not realized. This is the study done by Apartheid et al. In 2005. So, thank you all for मैंने आपको शुरू में मैंने जो निवेदन किया था उसकी आखिरी दो पंक्तियां इसके साथ मैं समाप्त करूंगा कि कंजर्वेशन और रिस्टोरेशन जो कहा जा सकता है कि एक ही सिक्के के दो पहलू या एक ही शजर एक पेड़ की दो शाखें हैं, तो इनको एक साथ चलना होगा कि हम कंजर्व करें, हम प्रेजेंट पोजीशन को पहले प्रोटेक्ट करें और बाद में हम इस दिशा में बढ़ें कि हम पास्ट में जो इकोसिस्टम रहा है उसको रिस्टोर कर पाए. तो मैं वापस से शुरू करता हूँ. समंदरी तरी खामोशियां कुछ और कहती हैं, मगर साहिल किश्तियां कुछ और कहती हैं, और यूं तो देखे हैं मेरी तीन आंखों में मंजर कुछ और, यूं तो देखे हैं मेरी आंखों में मंजर कुछ और, मगर अखबार की सुर्खियां कुछ और कहती हैं. ये डिफरेंसेस हैं जो तुम्हें दिखाया गया है और जो हमारे सामने है. और हम चाहते क्या हैं कि हम पहले शहर यानी हम जो सिटीजन्स ऑफ इंडिया हम पहले शहर की ख्वाहिश की बेंजोर पर रहेगी. दिस इज आल्सो कंजर्वेशन एंड इकोलॉजिकल रिस्टोरेशन कि हम पहले शहर की ख्वाहिश की बेंजोर कर रहे लेगी अमीर शहर की दिलचस्पियां कुछ और नहीं है. यहाँ अमीर हमारे लीडर्स हैं वो हुक्मरानों से है कि हम पहले शहर की ख्वाहिश हम मिलजुल कर रहे लेगी अमीर शहर की दिलचस्पियां कुछ और कहती है. थैंक यू वन एंड ऑल. थैंक यू डॉक्टर ममता शर्मा for providing me this space. Dr. Mukam Singh, our principal and pattern, and technical staff, Shri Shikhar Gupta, and dear students, and our delegates and colleagues, and our participants. Thank you.
Very good. Thank you, Dr. Sharma. And let me put on something. You said that you were not prepared, and I think you were fooling us. And you were really fooling us because the presentation was amazing, and I can see so much more message that people have enjoyed. People were thrilled to see you. So
Thank you, ma'am.
And it was a good session and everything like there's so much. So let me think about it. If you are not prepared, how you will present when you are prepared.
So मैं इस संबंध में बताना चाहता हूँ कि ये मेरा रिसर्च टॉपिक नहीं है, मेरी रिसर्च पार्टिकुलरली मैटर पोल्यूशन पे है। ये मेरी बुक का चैप्टर है, इकोलॉजी एंड एनवायरमेंटल स्टडीज, जो पीजी के स्टूडेंट्स, खासकर एमएससी और एमफिल के स्टूडेंट्स के लिए है, उनके सिलेबस के अनुसार हुई है। और उसका एक चैप्टर है ये रिस्टोरेशन। That's why I said it to you that I am not prepared.
So this is more amazing, Dr. Sharma, because आप दुआ करते हैं कि आप ऐसे ही पर्यावरण संरक्षण की किताब लिखते रहें और चैप्टर्स पढ़ते रहें और पर्यावरण बचता रहे। धन्यवाद आपका बहुत बहुत। थैंक यू सो मच। आप बहुत ही आदर और सम्मान के साथ में आमंत्रित हमारे बहुत ही डायनेमिक प्रिंसिपल है हमारे, और यही आशीर्वाद से वो इतना कुछ कर पाते हैं। बहुत ही आदर और सम्मान के साथ मैं आमंत्रित करती हूँ प्रोफेसर डॉक्टर मुकुंद सिंह जी को, जो इलेक्टेड और हमारे सर स्टेट इज ऑन योर्स।
आज विक्रम संवत 2019 पूर्वाभास परीक्षा अशोक के देखो एक स्मृति संकल्प संगीत सम्राट अलीबख्श की भूमि पूर्ण की भूमि और रहस्य राजा पृथ्वी गणी की तपोस है। इस प्रख्यात सविस्का टाइगर डे की धरा दुनिया की बलवत्तम भारत और भारत की रीढ़ भूमि राजस्थान और राजस्थान का सिंह द्वार बटुआ और अनवट महाराजा जयसिंह द्वारा स्थापित उच्च शिक्षा के क्षेत्र में दिया गया उपहार के युग में समान मैं आप सभी सुधी 25 देशों के 2000 डेलीगेट्स का 2100 और ऑनलाइन ऑफलाइन हो प्रिंट मीडिया सोशल मीडिया से जुड़े समस्त सुविधाओं महाविद्यालय परिवार वक्ता कितना भी अच्छा हो, वक्ता अच्छा होता ही है, वो अपने फील्ड का मकसद होता है, लेकिन जब तक होता है तब तक उसके वक्ता को खाते। इसलिए जो कीनोट स्पीकर्स, चेयरपर्सन्स इस मंच से दुनिया को संबोधित कर रहे थे, उनके प्रति तो मैं आभारी हूँ। अब उनसे अधिक आभारी उनका हूँ जो इस कार्यक्रम और जिनके लिए हम कार्यक्रम कर रहे हैं, होता है तो वक्ता प्रक्रिया। इसलिए वो सभी सुधीजन जो जुड़े हुए मन से जुड़ रहे हैं, उन सब के इस उम्मीद के साथ और इस उम्मीद को प्रमाणित आप लोगों ने किया है कि ये हमारा ISTTP-4 है, 3 हम पहले कर चुके हैं। इसी बीच 12 से 14 अगस्त तक हमने एक अंतर्राष्ट्रीय कॉन्फ्रेंस किया ऑफलाइन, और जिसमें 10 देशों विद्वान में आकर्षित कर ये सब होता और हमसे जुड़ी ये जनों की वजह से ही हम इस यज्ञ का विशाल धारण करते जाते हैं। आज के प्रथम सत्र में प्रोफेसर वासुदेव गोडुले कमला के महाविद्यालय नागपुर महाराष्ट्र में हमें अपना उद्बोधन किया और द्वितीय वक्ता के रूप में डॉक्टर L.K. शर्मा, प्रोफेसर ISC कॉलेज अलवर, आपने और हमारे तीसरे वक्ता डॉक्टर विशील धारिया HND यूनिवर्सिटी पाटन गुजरात हमें संबोधित करें। आप सभी के प्रति मैं कृतज्ञता ज्ञापित करता हूँ, साथ ही बात ज्ञापित करता हूँ अपने बहु समय से इस मंच से हमें समस्त स्थितियों लाभान्वित किया और उन्हें आप सभी का बार बार धन्यवाद इस उम्मीद कि आप सबका आशीर्वाद और स्नेह और समर्थन लगातार करेंगे। जय हिंद, जय भारत।
Thank you so much for your mindfulness and thank you for all the moral support and mindfulness. And because of this, we can do so much in very short time. So now we have another speaker. His name is Dr. Vishil Dharia. Dr. Dharia is working as an associate professor in the Department of Life Sciences at ISTTP University, Gujarat. He has done his PhD and having a teaching experience of 25 years and research experience of 30 years. He has 633 citations. Amazing, Dr. Dharia. 633 citations is a big thing. Your H index is 11. Your IQ index is 14. And RT score is 15.5. We are so happy to have him with us. His research areas are definitely ecology, wildlife and conservation biology, environmental biology, and animation. He is member of many academics and professional bodies. He has completed 18 research projects and his 2 research projects are going on. You are amazing scientists, trust me. There are students having a one PhD in the law finance and 2 hour working in the law school. You have got your contribution with many scientific journals and organizations. You have authored many books and only one thing, like there's so many awards, accolades. Your CD is very big, so I'm not reading it out. But I'm just saying that you were on spot here. This is what I want to do with the notice of all of my participants. Now, I'm not getting to the revelation. I would like to call upon Dr. Nishi Tharia. Please take Dr. Nishi Tharia co-host it. Dr. Tharia, I would request you to unmute yourself. Thank Dr. Tharia.
Hello, am I audible?
Yeah, Dr. Tharia, you're audible, but we are not able to see you.
Okay. Is my video is on? Like, can you see me?
The only picture is visible. You need to on the camera, I believe. इंटरफेसिंग में प्रॉब्लम आ जाती है हाँ इंटरफेसिंग में आती है उसके बाद से इतने प्रेजेंटेशन सुने सुबह कितना स्कूल से बोलने वाला आपको प्रॉब्लम नहीं Are you able to hear us, Dr. Raya?
Can you hear me?
Yes, we can hear you.
Okay, fine. I think there is an issue with my video, my camera doesn't work, but it's fine.
Yeah.
Yeah. And I can also hear some echo. So like something is wrong there. Okay. I think someone's microphone there in the call is on. Because of that, my voice is echo.
She can please hold.
Is it fine? Hello.
Yes, we can hear you.
Okay. So thank you very much, Dr. Mamta, for introducing me. And first of all, thank you very much to RR College and all the faculty members of the RR College, principal sir, and especially Dr. Mamta for inviting me again in this nice gathering. So I'm very much thankful to you. Please bear with me because I am somewhere out of my office, and that is why you will hear some background noise from my house. So please bear with me. Internet connection is also very poor, but I think my screen would be visible to you. I'm sharing my screen. So please let me know if my screen is visible. Is my screen is visible to you? Hello?
Yes.
Is the screen is visible?
Yes, yes.
Okay. Okay. And can you see the slides are moving? Slides are rolling? Is my slides are rolling?
Yes, yeah.
Okay. So I'm not taking much time in the introduction because Dr. Mamta has given a very nice introduction, and I'm very thankful to you, Dr. Mamta. I'm going to talk about the important risk that generally occurs when we are doing a research in our field, whether it is a life sciences, environmental sciences, or any kind of scientific research. And this risk is not like risk to us, but I'm talking about the risk which is which may happen during our research time or during our research, and that may affect our research performance or our research experiments. So I'm talking about these risks. I don't know who are the audience over here, whether they are researchers or students or scientists or faculties.
It's a combination of everything, Dr. Maria, here scientists and
Okay,
patients.
so I hope or I assume that like majority of the audience is the researchers. They are either doing research or they are conducting research, or they are about to start the research. They are in somewhere in the mid career, and I hope this presentation will be useful to you. And during your research time, you have seen many a time you have experienced that whatever you have planned is not working according. So this is what actually the risk. Like हमने जो प्लान किया है वो प्लान के मुताबिक हमारा रिसर्च नहीं जा रहा है. We are not getting the results. We are not getting the expected outcomes. We are not achieving the goals as per our desire, and this is all happens because of the potential risk that happens. So I would be talking about what is research, how to plan the project, how to plan the research project, what are the risk, definition of the risk, and how we can assess and manage the risk. What are the importance of this risk assessment, different steps involved in the risk assessment, and how we can do this risk assessment. As you see that most of the audience or most of the listeners are from the research field, and I'm sure that they know what is research or what actually the research is. So research is nothing but the systematic search for pertaining some information. So whatever information we are seeking for, if we seek those information using a scientific and systematic manner, then it is called a research. Research is also a careful investigation through searching new facts and investigating something which using the systematic and scientific methodology. So according to the well-known scientist P.V. we can define research as the systematic method of discovering new facts or verifying all facts, their sequences, relationships, visual explorations, and the natural law of the research. So this is what the theoretical definition of research. And when we are to do research, at that time, this definition mostly doesn't help, because during our research period, or the tenure of the research, many things will happen, and those things are known as the research. We can do research in 3 different phases. The first phase of research is a snapshot in a time, which is called the inventory, where we are giving concentrated efforts to determining the problem or research problem at a given time. This is what known as the inventory. Once we are having the sufficient inventory, then we will have the quality of the snapshot. That is what called as the assessment. So assessment is evaluate condition or value of something which does not have the strong time component. So here we forget about the time, but we are giving more focus, we are giving more concentration on the quality of the work, and that is what known as the assessment. And then at the end we are doing monitoring, and monitoring has a specific time component. So systematic observation of the parameters related to our research, which designed to provide information about the past, present, and the future, which is known as the monitoring. So when we are doing research, we are these 3 phases, which is inventory, assessment, and monitoring. Is my voice is clear?
Yes, you want to see Dr. Rajan, please go ahead.
Okay.
Yeah, you very well.
Okay, then what we do is most of us who are in the field of research or in academia, we are doing the projects. And projects I can define as a group of interrelated activities which results into a designated to achieve the specific time limited task. So when we are doing research, but that research is having the strong time component, at that time our research is converts into the research project. Some research are long-term research which has been started, but it doesn't have the end time. But many of our research work, they have the start time and the end time. And the research work which has a start time and end time is known as the research project. So, like research project is always turn out into a successful project when we have a designated project plan. So every project when we start, before the starting the project, we should plan it in such a way that our actual situation, which is known as a research problem, can convert into the desired situation, which is known as the research goal. So when our problem converts into a research goal or the achievement, when we at that time we can say that our project is successfully completed. So what is the process of this research project planning? Like we are always start with the situation, which is the research problem, and then we need to plan the situation. After that, we need to implement the project, monitor the project, and finally evaluate, review the project. So our situation will change. It converts into the goal, and we can say the project is over. So these are the different steps that I can define for planning of a project. First thing first, we should have a goal, our clear goal about the research. Using our goal, we can fragment our goal into several objectives. Objectives can be further fragmented into a smaller pieces, which is known as the parameters. And once we know the parameters of research, we can define the strategy. Strategy is nothing but the experimental design or the research methodology by which we can achieve our goals. Finally, once we have the defined strategy with us, we can put the strategy into different tasks. Here, the parameters are nothing but the measurable output or outcome of research. So we cannot measure our objectives. We cannot know whether the objective is achieved or not. But if we want to know whether the objective is achieved or not, then we need to measure. And for that, we need to measure the parameters. So every parameter will tell us whether how far we are from the objective, achievement of the objectives. During the strategy, we have to do the risk assessment. So whatever I'm talking about here is not during the project, but it is before the project. The risk assessment should be always done before we start our research. And then during the task, we can define the timeline. Which task will be completed, started when and completed when. What human resource we required and what financial resource we can require. So all these things we can talk when we are talking about the task. But today I'm going to talk about the risk assessment. So we can prepare the research methodology strategy of our research in a nice way. So what is the risk? Risk is the quantifiable likelihood or loss or less than expected returns. When we expected something more and when we are not getting that much thing from our research, that can be a potential or possible risk. We can assess the risk by process which estimate the likelihood and expose people or animals may have effect of that risk, known as the risk assessment. So here we try to know the likelihood of that particular risk during our research period, which is known as the risk assessment. And risk management is what the logical and systematic method of identifying, analyzing, treating, and monitoring those risks in any of the research activity, which is known as the management of the risk. Because risk is a very common factor. Whenever you do anything, if you are going with your car to some place, there is a risk. If you are just getting down with a staircase, there is a risk. So risk is everywhere whether we are doing research or we are doing any activity during our life, there will be a risk. But the important thing is how we assess that risk and how we manage that risk. This is very important. And particularly in our field, in the field of environmental science or in the field of life sciences, when the risk is managed by a researcher, then we can at least minimize the risk that will help us to complete our project or achieve our goal. So risk assessment is very important in our research because it will unveil the potential event which may occur during the research period, during the tenure of the research. It can give us an opportunity to manage those risks. If we have done assess the risk, we can manage the risk. It can make best use of available resources. If we have done risk assessment, then we can do the best use of the available resources. What kind of resources? Financial resources, investment, insurance, healthcare, government, and other ecological results. This all comes under the risk assessment. Disclose the scope and likely events to occur. The risk assessment will also tell us that what can happen in future or what are the chances of this particular risk can happen during our research period. And it will also help us to get the better funding for our project. If you need more funds, you need to do more risk assessment. Because many agencies, many funding agencies, they generally don't fund if you have not covered the risk assessment portion. So when you write the proposal, you should add the component which is known as the risk assessment. So how we can do the risk assessment? So there are 5 steps of doing the risk assessment. Step 1 is establish the context. Step 2 is to identify the risk. Step 3 is to analyze the risk. Step 4 is to evaluate the risk, likeliness of the risk. And the final step is to manage that particular risk. So first we have to identify and analyze, evaluate, and finally we can manage. We can prepare a plan by which we can manage the risk. This is what known as the risk treatment. Dr. Mamta, his microphone is on, so my voice is just bouncing down.
Very clear. There's no problem. No reason I can articulate very clearly.
Because in the hall itself, somebody is like having a phone or their Google Meet is on and their microphone is on. So like my voice is bouncing down. So it is actually harassing me to give the talk. So let us start with the first step. Now it is okay. Thank you. Thank you, Dr. Mamta. So let us start with the first step, which is known as the establishing the context. How we can establish the context of our risk or for the risk assessment. So first thing first, we should know the nature of the study, like what kind of research we are going to do and what is the nature of the study, whether it is a field research, whether it is a laboratory research, whether it is a clinical research, what are the things which are going to involve. Like there are much more traveling, there are much more work in the laboratory, there are much more work in the library, there is more reading. So what is the nature of our study? This is the first thing that we need to know while we are establishing the context of the risk assessment. Then the inherent risk. What are the risks which is already happened during this kind of studies and what are the priorities of those risks? Once we list those things, once we identify those things, then we have to monitor it, we have to review it, we have to again do some communication and consultation with others, and then we can make a final context establishment of the risk. The next step is identifying those risks. Now we know what is our study, what is the nature of our study, and what are the potential risks that may happen or that are already happened during some earlier project. So we can now identify the risk. And for identifying the risk, the first question that we have to ask ourselves is who is involved and who is affected during the project tenure, during the research time. who are the people, who are the animal, who are the community, who are the society, who is going to involve and affected through this research work. And how we can know this? We can just know this by the past events. So we have to review some literature, we have to contact some of the researchers, our seniors, and who have done this kind of research. We can just communicate with them and we learn about the past events, so what was happened in the past. Then we can remove those things using the future developments. What was happened in the past and what cannot be happened at present because of the developments, so that we have to think. Then we have to list the fates, what can happen during our research work. And again, we have to do monitoring, we have to do review, we have to communicate and consult our seniors or consult some external evaluators. And we have to talk with them about the past and future development. And we have to show them that whatever risk ideas or whatever the risk we have identified and list. So nothing, in short, if I want to say, we have to make the list of all the identified risks. Say, for example, if I'm making a list of my own research, and if I want to make the list, my first risk is I'm not getting the permission to work in the forest. This is the first important risk. If I'm not getting the permission to work into the forest, into the wildlife, I cannot do my research. So this is the first risk. Second risk is I don't have a vehicle to move in the forest. So mobility is my second risk. Third risk is I don't have a proper trained manpower to work with me. Third risk, I don't have a potential funds, maybe another risk. I don't have the equipments, maybe the another risk. So these kind of risks we have to list when we are making a list of the potential risk or the past events. And then comes a very important part of the risk assessment is the analyzing of the risk. We can analyze the risk by the likeliness of the risk event to happen. ये risk होने के chances कितने हैं? That we have to study, that we have to think, that we have to study, or that we have to like brainstorm using the literatures, using the past events, using the experiences of our seniors. We have to prepare the likeliness of the risk to happen in our project. How we do it? By the probability. What is the probability of this risk is to be happen? Like what is the probability of not getting the permission to work in the forest? If the probability is very high, then the likeliness of that particular risk is very high. But if it is very easy to get the permission from the forest department to work in the forest, then this risk is considered as a lower quality risk. After that, the frequency. How much time or how many times the same risk is going to happen during the project. Now, like permission is to be taken for the only for one time. So the frequency of this risk is very, very low. But if every time you have to take the permission, or if every time you need a mobility, then the frequency of the risk is very high. Then we have to consider, for the analysis of the risk, we have to consider the impact, cost, and consequences of the risk. We can do it by two different ways, economic and ecological. Social impact, social cost, and social consequences, and the political impact, political cost, and political consequences. So when we are analyzing the risk for the impact, cost, and consequences, we have to take into consideration three different aspects. One is economic or ecological aspect, social aspect, and the political aspect. Again, we have to review our own list, our own analysis. We have to communicate with the external evaluator so we can get more ideas about the analysis. And then we have to do the next step of the risk assessment, and that is the evaluation of the risk. So now हमने जो list बनाया है, whatever list we have prepared, whatever likeliness we have prepared, we have to rank them, which is the highest ranked risk and which is the lowest ranked risk. How we can rank them? On the priority, category of the risk, and the likelihood of the risk. So using these three aspects, we have to rank whatever list we have to prepare. Like in my research, I have prepared a list of 7 different risks. So of these 7 different risks, I have to rank them, which is the first one and which is the lowest one. We can also add the possible consequences of this risk. And again, we have to communicate, we have to consult the external evaluator to final rank for the final ranking of the risk. Once everything is done, then we have to put our risk into this table. So this table is made on the likeliness or likelihood and consequences of the risk. So whatever risk we have listed on the basis of the likelihood and consequences, we have to put those risks into these different cells. So this is cell number 1, cell number 2, cell number 3, 4, 5, 6, 7. So these are the cell. So जहाँ पे मैंने लिखा है severe, high, major, moderate, this is the type of the risk, but we have to add our risk. If the likelihood of the risk is extreme and the consequences is almost certain, then those risk is known as a severe risk to our project or our research. But if the risk is, the likeliness of the risk is very low or negligible and the frequency of this risk is moderate, then we can say that particular risk is either major or the moderate risk. So once we put all our listed risk over here, we can just have an idea that how many risk factors are severe, how many risk factors are significant, or how many is low or very low. So if you have more listed risk over here on the low or very low part, then you are good to go. You can start that project. But you have more number of risk on this corner of the of your table, then there is a need to manage those risks, or there is a need to wait and first come first overcome those risks. So most of our risk factors that comes towards this side of the table. So we need to go on this side, like you can say right corner of the table, where risk is moderate, low, or very low. If your number of risks are higher on this side, severe or high or major, then you should avoid those activity in your project, in your research, because that will give you more number of risk. Once we identify, analyze, and assess those risks using that table, then important is how to treat them. We can treat them based on the priority. The risk which is more higher, risk which has more impact, risk which is severe or major risk, those risks are on the priority list. They are on our first priority. But those risks which doesn't have any effect on our research, like which are either moderate or low or very low, then they will go into the lowest priority. So we can treat the risk on the basis of the priority, strategic, optional. These are the two different segments of the priority: strategic priority and operational priority. Then based on the resources. So do we have the resource to overcome the risk? What kind of resources? Human resource and financial resource, as well as the technical resource. If we have these three resources, like many of the risks can be overcome. If we have the human resource, if we have the financial resource, if we have the technical resource, then we can minimize those risks, or we can just convert the major risk to the moderate risk, or the severe risk to the low risk. Again, this treatment methodology, we have to consult, we have to monitor it, we have to review it, and we have to consult some external evaluator, so we can get more ideas about the treatment of the risk. Now, if someone of you is doing a research in the field like me, like most of my research is a field research, where I work with the wildlife, where I work in the forest, or where I work in the natural areas, where the wildlife is involved in your research, And when the wildlife is involved in your research, you have to take care about three different kind of wildlife: carnivores, herbivores, and the minor wildlife which are involved. When the big animals, the major animals, large animals are involved in the risk, whether it is carnivore or herbivore, then the risk assessment is a different, you have to do it differently. But when the other minor animals or wildlife is involved in your research, like civet, snakes, birds, then you have to do risk assessment in a separate manner. So these are some of the example of the major animals, or we can say large sized animals, whether they are carnivore or herbivore, that you have to consider while you are doing the risk assessment. And for them, the first important thing, if you are going to handle those animals, right? Sometime we are going to collar the tiger, sometime we are doing the radio collaring of leopard or bear, sometime we are doing the like measurement of the animal. That time we have to handle them. Sometime we are doing bird ringing of the birds, like there are lot of research on migratory birds which is going on, where they are handling the birds, capturing the birds, handling the birds, and they are ringing the birds. So in this kind of time, like in this kind of research, we have to follow the handling instructions. Like we are handling the wildlife, so we have to take care about the risk. Now in this case, there is a risk for both: risk for the wildlife or the animal which is involved, as well as the risk to the investigator or to the researcher. What are the risks? The first important risk is the infection. Like your infection can transmit into the wildlife, or the wildlife infection that can transmit into you. Then, because of this infection, spread of the disease can be another risk. Introduction of new disease in the human community, or introduction of the new disease to the wildlife community, that is also a risk. Like new viruses which are coming in our society, in our human community, this is the result of this kind of improper handling of the wildlife. Same way, we can also introduce the invasive species, which is not native to your area. Sometime during the handling of these kind of animals, we are introducing, knowingly or unknowingly, we are introducing the another species or the invasive species in our native area. So how we do the risk management plan? What is the planning for the risk management? Whatever risk we have identified, listed, analyzed, and prioritized, we have to document those risk management into the risk management plan. We have to record the allocated responsibilities. If this risk happen, then who can be treated or who can be responsible. So we have to allocate the responsibilities of the record. Then we have to monitor it. Assumptions of the risk, because risk हो जाए उसके बाद, मतलब कोई इवेंट हमारे रिसर्च के दरमियान अगर कोई इवेंट हो जाती है, उसके बाद उसका एनालिसिस और मैनेजमेंट करने का कोई मतलब नहीं. So whatever risk we are planning, whatever risk management we are planning, this is all based on the assumption and the review of the past events. So if we know the past event, if we know the past risk, then we can assume them, and by assuming them, we can do a better management plan. So what are the good starting point? Like if you think that this is a good idea to do a risk assessment or risk management plan before we start our research work, so what are the good starting point? The best thing is that everyone do, and if we are not doing, we should do. This is the thorough scientific literature survey, because this scientific literature survey will not tell us only about the methodology of the research or the causes and consequences of the research, but this thorough scientific research review or the literature review will also tell us about the potential risk that is going to happen during the research period. Then the field data from previous occurrence, like if you are doing a field research, then, or if you are doing a laboratory research, again you have to check the previous occurrence of these kind of risk in your in the similar area. And You can also collect the information from the locals. So local information can be also important as a good starting point of risk assessment. And finally, the communication and cooperation, collaboration, communication and cooperation. This is very important while we are doing the risk management or risk management plan. Once we have the proper risk management and risk consideration, then we can nicely prepare the budget, or we can prepare the adequate budget for our research project. What the questions that one should ask when we are preparing the project, while we are preparing the budget for the project? Number one is, how many person and what qualification my project need? What is the need of my project? What kind of human resource I need? So we have to list them out. What is the sample period, like how long I'm going to take the sample? That will also help us in the timing, budgeting, and the risk assessment consideration. How long the analysis will take place, whether it is the analysis is going to be in the field or the analysis is going to happen in the laboratory. So this is the third question that I should ask when I'm preparing the budget and timing of my research project. What equipments and supply that I require, and out of these equipment and supply, what are the existing in my lab, and what are the new hardware, software, instrument that I want to buy. So this will also unveil the amount we require, or the budget we require for the instruments or the equipments. Then what is the data collection and management plan? Do we need a legal permission for conducting this research? And what other factors that to be considered, such as transportation, storage of the sample. If we are, sometime we are working on the water, and for that we need to store the water sample into at the 4 degree or like less than 4 degree temperature, then we need the huge refrigerators for our samples. Sometime we need to transport this sample from our field site to the laboratory site, so we need a transportation. Sometime we also have to consider the weather factors. We are working on some seasonal research work, then the weather factors are also considered. So these are also considered while we are doing the risk management plan, while we are doing the timing and the budgeting for our research project. Then finally, what is our end product? What is the message that we want to convey to the scientific society, or what kind of message we want to convey through our research to the society? So if we know what is our final goal, we can prepare the risk assessment plan, or we can prepare the budgeting and timing of our time frame of our research project very adequately or comfortably. Finally, whatever research we are doing, this is for the conservation of nature and natural resources. So it is just a state of harmony between man and the land. Very short presentation I have prepared for you guys, and I hope that this presentation or this talk will be helpful in your future research or in your current ongoing research. If you have any suggestions, if you have any ideas, if you have any questions, if you don't want to ask right now, you can write me on my email. So this is my email, my name, and gmail.com. And once again, I would like to thank to the organizers, RR College, especially Dr. Mamta Sharma, Dr. Hukam Singh, and you all who are listening this talk. Thank you very much.
Everyone is very happy to hear you. And there's a message in my WhatsApp that people want to have your presentation. So if you really wish to share with the participants, please do share with me on the WhatsApp so that I can share it with WhatsApp. If any questions, please write in the chat box. I think it's one of the appreciation for you. So if there are no more questions, let me formally thank Dr. Zalaria. Thank you so much, Dr. Zalaria, for joining us. Definitely it was a wonderful presentation. And me, along with the participants and all of our appraisals, are very, very thankful for such amazing and wonderful presentations. I know you are we work.
Finally, my camera is working, Mamta.
So I know you are people, but you took all the time for us, and that's coming. Thank you so much, and we appreciate your presence. And we have a fabulous day. So let's take up to the end of the third day of the ISTTP-4, rather before the day of ISTTP-4. I would like to extend my thanks to all the speakers who are very learned and knowledgeable scientists for the field, and they have spared their valuable time with us here in this chamber. I would like to tell all the speakers and meet the organizers and all the participants are very happy and delighted to have you here with us, and I hope you all have that. So this is from the national organization I was reading before. I hope it might achieve we are signed off from the campus and others become the members of all tomorrow sharp and 11 a.m. I hope that's there.
Thank you. Bye-bye.
Bye. Thank you so much. Thank you, everyone.
Yeah, and if there is any question from any of the participant, you can mail me or you can send me those questions. So I will try my best to answer those questions. Thank you, Mamta.
Thank you
Bye-bye.
so much.
Ciao. Ciao.
Bye. Bye, everyone.